My name is Samantha Stone, and today we are going to be focusing on the gas laws and how they apply to our everyday lives.
Ever wonder what's at the end of a rainbow? A unicorn's butt. It's useful,
no,
as you know.
not-
What you don't
not
know
that
is
kind
it
of
makes your
gas.
poop smell
No.
good.
I got gas needs to pass from out my dress. Let one go, let one go. Can't hold it in anymore. Let one go, let one go. Just push and give it wide for.
So the gas law can be represented by the following equation. P1 times V1 divided by T1 equals P2 times V2 divided by T2, as seen here. This equation comes from Charles' law, Boyle's law, and Guy-Lussac's law. But today we will be focusing on Boyle's law and Lussac's law. The equation for Boyle's law is P1 times V1 equals P2 times V2. So basically, when the pressure goes up, the volume goes down, and vice versa. When the volume goes up, the pressure goes down. Guy-Lussac's law is shown as P1 divided by T1 equals P2 divided by T2. So as the pressure goes up, the temperature goes up, and when the pressure goes down, the temperature also goes down. These laws apply to many things throughout our daily lives, like the fire extinguisher, for example. You can find a fire extinguisher in almost any building because it's required by the state to, maintain safety in case of a fire. Now, there was once a time when people didn't have fire extinguishers. They did have things called squirts that would squirt water onto a fire, but a water source was needed nearby so that could happen. So what happened back then when there was a fire and no source of water nearby? Or when there was, say, a cute little bunny that was on fire and there was no way to save its life fast enough because there was no water to put it out or anything else to put it out with. How did they save that cute bunny's life? Well, we just discovered an ancient video of this exact situation and how it was handled before fire extinguishers were invented. So to prevent cute little bunnies from burning to death and, to prevent small fires that could potentially grow into huge fires that would burn everything down, the portable fire extinguisher was invented. In 1818, a British man named George William Manby invented the first portable fire extinguisher, which has similar features to the fire extinguishers used today, primarily because the ones that we use today are based off of the ones that he invented. The first fire extinguisher was a copper cylinder that held 3 gallons of a mixture of potassium carbonate, K2CO3, water, and compressed air. The compressed air was used to help spray the solution through the narrow tube that was then aimed at the fire, obviously, because how else are you supposed to put out the fire? In 1866, François Collier, a Frenchman, contributed to the development of the fire extinguisher. He introduced the soda acid extinguisher, and no, it did not shoot soda through the nozzle, but that would be pretty cool if it did. Anyways, the soda acid extinguisher was filled with compressed air, sulfuric acid, and sodium bicarbonate solution. The reaction between the sulfuric acid and the sodium bicarbonate solution produces carbon dioxide gas, which increased the pressure and forced the water out through the nozzle. The mixture of the liquid and the carbon dioxide then smothered the fire. So if you didn't already know, the CO2 cuts off the fire's supply of oxygen and therefore puts it out. In 1881, Almond M. Granger brought the soda acid fire extinguisher to the U.S. with some improvements. By the 20th century, improvements were made and the fire extinguisher was becoming more modern. In 1912, the chemical foam extinguisher was created in the U.S. It shot carbon tetrachloride out to smother the flames and was therefore known as a CTC extinguisher. However, the chemicals in the CTC extinguisher were toxic and were a risk to the public's health, so the people stopped using them around the 1950s. But in 1924, the carbon dioxide extinguisher was also being invented in the U.S. by the Walter Kidd Company. It was a tall metal cylinder that held about 7.5 pounds of CO2. So now with the history of the fire extinguisher out of the way, I'm going to show you how to use one, and I'll explain how it relates to the gas laws, and yeah. But first we need a fire extinguisher. Got one. Let's do this. First, pull the safety pin. Then stand 6 to 8 feet from the fire and aim at the base of the fire. Squeeze the lever and sweep side to side. And try not to inhale anything, like I did. A fire extinguisher is like a giant aerosol can. It functions in the same way and uses the same gas laws to get the substance out of the pressurized container. Usually there are 2 different substances inside of a fire extinguisher. One of them can be a solid, liquid, or a gas substance that fights or puts out the fire. And the other one is called a propellant, and it's a pressurized chemical that makes the firefighting substance come out when you squeeze the fire extinguisher's handle. Earlier I talked about how Boyle's law related to the fire extinguisher. The pressure in the container needs to be high, so the dial will be on the green area right here, and that's how you know that your extinguisher is ready to be used. When the pressure is high in the container, or when it's on green, you know that the volume of the gases and the chemicals inside of the extinguisher is low. So once we squeeze this lever right here, the pressure of the container decreases, which causes the volume of the gases and chemicals to increase, which makes the foam or powder or water or whatever it is to shoot out of the nozzle. So Gay-Lussac's law, which we also talked about earlier, also relates to the fire extinguisher. So when the pressure is released, or when you squeeze the handle, which releases the pressure, the temperature of the extinguisher will decrease. You will be able to feel it. It will start to feel colder, and it might even precipitate ice on the outside, especially with the older extinguishers. And that's how Gay-Lussac's law relates to it.
Using fire extinguishers can help you save your mother, kids, and others past. That's just what I'm talking about. The P stands for pull, so you can go and pull that pin out. Now the A stands for aim, you can pull the hose out. Then you start to squeeze, that's what that first S is about. Then you sweep it from side to side, the other SC. When you try to put out a fire, do it correctly. Never turn your back on the fire. Always keep your eyes on what's burning so you can get out into your place of safety. That's what I'm talking about. Make sure all of your people are out. No need for running and wilding about. You